Hi Intermediate, the first section we're going to start with is 3.3, and that is absolute value equations and inequalities. Now in general there's three rules for this, and I'll go over that first and then I'll go over some examples. Okay, so the first rule you have is when the absolute value of x is equal to a. So if this is equal to a, then what x would be is positive or negative a. Now that's shorthand for x is positive a or x is negative a. So that's the first case, when you have an equal sign. The next case is when you have a less than, and you can have a bar or no bar here at the bottom. That just means that the boundary value is included if there's a bar. We'll talk a little bit more about that in a moment. Now if you have this case, what it actually gives you is a span of numbers. So x is actually going to fall in between negative a and a. It's going to fall in between a span of numbers. And then the last case, if you have a greater than, if you have a greater than a, if you're greater than or equal to a, then that's two answers. So that means you're going to get one case that looks very similar to what you originally have. Or you're going to get a second case where you have to, let me make sure I'm saying this a little clear. For the greater than case, you actually have two distinctly different answers. One where x is greater than a, and one where x is less than or equal to negative a. So for some people who are very visual, it helps if I sort of draw these. So in the first case, most of the time you get two dots. So if x is plus or minus a, that's two dots like this. The only exception to that, and you may be able to figure out what it is, the only exception to this is 0, because 0 is not positive or negative, it's neutral. So if x is equal to 0, that's just one answer. And again, this one I said this would sit in between negative a and a. So this is like a whole segment. It's not just two dots, it's actually a whole segment. And again, if you have the bar, it's closed on the ends. If you do not have the bar, then you would actually have open circles here on the end without the bar. Oops. And then the last case, the greater than, that's actually going to put you on the edges of the number line, like this, on the edges. So right now we're in one dimension. That's why I'm just on a number line. I'm not on our Cartesian plane. If I'm on a Cartesian plane, this actually looks like a V. We're just in one dimension when we're solving this. So that's why I'm just staying on a number line. Okay, so those are in general the three cases. I'll give some examples and then I'll show you just some like special cases, okay? So let's start with the first rule. All right, if we just take, oh, my brain wrote that backwards. Okay, so let's start with the first rule. So the most basic case would be to say you just have something like that. And so what the rule says is if you want to take off the absolute value, what's on the outside has to be equal to the plus or minus. So what's on the inside is equal to the plus or minus what's on the outside. So for this case, that would mean that x is plus or minus 5. Which is actually true, right? Because the absolute value of 5 is 5, and the absolute value of negative 5 is 5. Okay? So you're just trying to figure out, like, what can x be in here that if I took the absolute value of it, it would be 5. And as we know, the absolute value means we're going to make it positive. Alright, now as these get fancier, the general idea is that you want to isolate the absolute value before you use the rule. The rule only applies to when the absolute value is all by itself on the left. So as I look at this problem, the absolute value here has a -7. So I actually need to move that to the other side. I have to get rid of that. Okay, so I'm moving the 7 to the other side. Since it's going on the other side, it has to be opposite sign. Okay, so now it's on the other side, and now I can use the rule. So now as this gets fancier, make sure you understand the rule. It's saying whatever in here, no matter how small or how enormously large, whatever is in here, if you take off the absolute value, is going to equal to the plus or minus what's on the other side. So that means that whatever's in here is going to equal to, I'll write it shorthand first and then I'll fix it. Okay, so that means whatever's in here is going to equal to the positive and negative of what's out here. That's how you pull it out of absolute value. You say what's in here is equal to the positive and negative of what's over here. I'll break it now in the next step. So it's going to equal to positive 11, and this stuff is going to equal to negative 11. So this kind of idea, and then you go ahead and solve it. So you just want to get the 3 out of there. Okay, so we get the negative 14, and we have the 8. So remember, it's just 2 dots. Alright, let me try that again with you. I'll do a different variety. Okay. Now in this case, the absolute value is already isolated. There's nothing like outside of it. There's nothing outside of it. So I don't have to worry about that first. So I can say what's inside is equal to the positive and negative of what's outside. All right, now I can break this up. And I can just finish solving it. When you hand in your homework, you don't have to like make your answers very elaborate unless you want to. Some people want to. I just put down what I need and I'm good. Okay, so that's another example of the first case. Okay, I'll do one more of the first case and then I'll skip to the other cases. I try not to make the videos super long, so when I finish this last one, I'll also end this first video. Alright, so let's do one more of the first case. Alright, so the thing that you always need to do first is isolate the absolute value. So that's what I'll do first. So I have to get off this 3 here. So I'm going to divide off the 3 to both sides. Alright, now the absolute value is by itself. So now I can take it out of this form by using the rule I showed you. Okay, and then you just solve it out. Let me just see, let me just eyeball your homework real quick. And let me see. Okay, I'll get into the special cases. I'm just trying to see. All right, you know what? Let me just grab one. I'm just sort of looking like, I'm not sure how comfortable you guys are with maybe like fractions. So let me grab something like that one there, number 12. I'm just going to write it for you guys out. So 3 over 4h plus 8 equals to 7. Okay, let's do one of those. Just start eyeballing what's in your homework so I can make sure you're prepared to do this. All right, so there's nothing around the absolute value. I don't have to say it's number 12. I just wanted to grab something like in your homework. All right, there's nothing outside of the absolute value, so we don't have to worry about that. And if h is in the middle, that would be equivalent to h being on top, if you didn't know that. So in the middle or on top is fine, just not near the bottom. All right, so I can go right away to taking off the absolute value because this is isolated. If this wasn't isolated, like in a problem like this one, you'd have to move the 9 first. Right here, you'd have to move the 6 first. So it's already isolated, so I can go right to solving. I'm just putting the h on top. I think students like that a little better. Alright, now it just depends how you play ball here because some people don't like the fraction. So you can get rid of the fraction first, you can get rid of the fraction later. It's just up to you. You can start to isolate and then get rid of the fraction. So I'm just going to get rid of the fraction right away. And how you get rid of the fraction is you multiply everybody by the LCD. And when you do that, that'll get rid of the fraction. Okay, if you don't like fractions, you could just cancel them out right away or at halfway through, whichever way your brain does it. Okay, divide off the 3. You will get the occasional fraction, so make friends. Be nice, play nice with your fractions. Not everybody's favorite. Okay, just gonna throw this on the number line. Okay, gang, that's it for this one, equal signs. I'll pick up and do another case in the next video. Hope you enjoyed it. Catch you again. Bye.